Okay, in this section we're going to review a little bit about Chapter 3, which is on the dipole, which basically means two poles. Different systems can have 3 poles, 4 poles, 5 poles, multi-phase systems, but overall there's a high and a low pole that we're talking about, and this concept right here, which we're going to walk through a couple examples, is the basis, or you can say the foundational understanding for how you turn the ether into work. How do you get something very symmetrical and homogeneous sitting inside a space to actually do work? And that is by creating a dipole, which means, as I mentioned, Tom Bearden, for example, may say you want to break, the dipole breaks the symmetry of the virtual photon flux of the quantum mechanical vacuum. When you say it breaks the symmetry, that means you're taking it from a symmetrical state and you're making it an asymmetrical state where you have a high and a low point within that quantum flux, if you want to use that terminology. I like the ether terminology. I like how Eric Dollard says polarize the ether, because in simple terms that's exactly what you're doing, is you are polarizing ether. And that is what every dipole does, and we're going to go through a couple examples so you can basically see what this means. Okay, so let's take a look, and let's just say this is the ground, and we have gravitational potential moving down, and we'll get into what gravity appears to be later on, but I'm just going to show a simple example. So let's just say this is the ground. Now let's say on this ground we have a piece of wood like this laying down, and let's say there's a ball on this piece of wood right here. Does the ball roll? Well, if this is level on flat ground and the board is flat and that ball is just sitting there and it's a perfect sphere, and that ball will not roll because there is no dipole. There is no potential difference between here and here in relation to the board and its position to the ground. So if we took that board and we elevated it like this, we now have a potential difference between here and the ground right here, and mass times gravity times height, mgh, and we'll go over those simple little junior high school equations later. But what you've done is you've created a potential difference within the gravitational field. What you've done by creating a potential difference is creating a dipole. You have two poles, which you have a high pole here and you have a low pole here, which means as the gravitational potential is coming down, it can push on the ball, roll it down here. It's going to hit the ground, make a little bit of heat. You got a little bit of rolling friction here. The ball is going to roll over here. And what the point to this is basically showing that this is just one example of creating a dipole, which is two poles in order to take something that's symmetrical and getting it to do work. And many people are conditioned to believe that gravity can't do work because they're going to claim that it's a static field. That's complete nonsense, and we're going to go through that and completely destroy those arguments with nothing more than 3rd grade math and 7th grade Newtonian equations, which are the equations themselves give the right number, but they've been interpreted upside down and backwards. Conventional mindset has interpreted them inverse from what they're actually showing, and we're going to be going through those. And we'll go through some more examples of a dipole. So how does a battery work? Let's say you got a battery right here, and you got plates in here. And let's just say you got a negative pole here, you got a positive pole here. And let's say you got a light bulb in the circuit. Well, pretty much everybody is going to say if this battery is charged up, it's going to light the bulb and it's going to run out of charge. Well, the reality is that a battery doesn't run out of anything when it goes dead, and when you charge it, you don't fill it with anything. You're not adding or subtracting any mass or anything to the battery. All you're doing is rearranging the chemistry inside. And what I mean by that is when you charge a battery, you're separating the internal charges when you run current through it, or you can actually do it with voltage potential. You can charge a battery, and that's what we do with Tesla at TeslaChargers.com. We utilize both. Is that when you're charging a battery and you're running current through it, what you're doing is you're taking disordered, symmetrical, homogeneous chemistry, in other words, and you're bringing the positive charges this way, and the negative charges are going this way. So when you charge a battery, all you're doing is you're separating the internal charges in the battery to create a high potential here and a low potential there at the terminal of the battery. So what is that doing inside of 3D space? Well, I shouldn't really say 3D because there is no such thing as three-dimensional space. Space is singular dimension. Space is one dimension, but there's three coordinates to be able to show the position of something within that singular dimension of space. And you really have to think about that, not too hard to see that that is actually what makes sense. And the reason is because if you're watching this video right now, if you're in a different dimension than I am, and dimension equals a different place within the same kind of space, if you're in a different dimension than I am, you couldn't even be watching this video right now. You couldn't go on the website, you couldn't mail something in the mail to me, because you're not sending a letter to me in a different dimension. You're still in the same singular dimension of space, but you are at different coordinates, and coordinates are not dimensions. Okay, now what we're looking at here is a high and a low potential. So what we're looking at is, if you have a battery here, and let's say you got the terminals right here, and let's just say the ether is very symmetrical and homogeneous, you know, all around the area of the battery. There's no potential difference, but when you charge the battery and you create a high, which is a plus, and a low, inside of that homogeneous ether, what you do is you break the symmetry. The positive charges of the ether move towards this pole here, and the negative charges of the ether are available here. So what happens is the ether organizes itself at these poles of the dipole, because that battery created an asymmetrical situation within that homogeneous and symmetrical ether. Just like lifting a board on the ground, you create a potential difference for the ball to run down. You create an asymmetrical relationship between that ball on the board and gravity. And what the battery does is it also creates a ramp. It creates a high and low point within the ether. So what happens with the ether is that the positive potential of the ether moves towards the positive terminal, and it flows over the surface of this copper wire this way back down to here. There's an implied anti-negative charge moving to the negative pole and moving backwards against it in that direction towards the positive. So where does the electron current come from? Inside of the copper wire itself, the copper has 3 electron levels. We'll say 1, 2, 3. And the electrons out here in that 3rd level are the most loosely bound. And because they're so loosely bound, it's easy for them to jump orbit. And so what happens is, as this positive potential, it's positive, this etheric flow, which some will say is the heavy side flow moving over the surface of the wire, it does not go through the wire, is positively charged. And what happens is a little bit of that is attracted to those electrons inside of the copper wire, and the electrons in the copper itself are attracted towards the positive charge, and they start moving in the direction of the positive terminal. So those electrons, which you're going to measure as electron current, is moving towards the positive pole, did not come from the battery because you never filled it up with a magical charge anyway. All you're doing is potentializing the electrons in the copper wire itself to be able to move towards that. Because the flow over the wire is positive, it's going to attract something that's negative, which are the electrons. And these electrons are moving very slow and sluggishly in the direction of the positive terminal. Very slow, couple inches per hour, only a couple inches per hour. And this is how a battery polarizes the ether. Now, part of this positive charge hits this positive terminal, comes in, or the negative charge, and it's going to come through here and eventually encounter organized negative charges. The positive comes this direction, goes this way, and encounters organized positive charges. So basically half of the potential energy you have here, the higher the voltage, the higher the ramp. The lower the voltage, the lower the ramp. Okay, so what happens is, as the light bulb is being lit, part of the potential energy there, see, that potential is moving over the circuit. And when it hits these electrons and you're getting this resistance in here, that's work. And what it does is it disorganizes the polarized chemistry in the battery back towards equilibrium, which means the voltage is going to start, if it's at 12 volts here, it's going to start going down. And when it goes down, down, down till it's dead, it doesn't go dead because it ran out of something. It goes dead because the chemistry comes into an equilibrium, which means the high charges are no longer here, the low charges are no longer here. They've equalized, and so the ramp is back down to laying flat down on the ground where there's no more potential difference for the battery to be able to do any more work. So that's an electrical example of what a dipole is, and I showed you the board with the ball. That's basically a mechanical example of a dipole. But in both situations, you're creating an asymmetrical situation for the ether, and the ether is the same whether it's for gravitational potential, whether it's for electrical, and this is where the potential comes to potentialize electricity anyway, is basically polarizing the ether, and that's how you get work out of it, and you do that through a dipole. So this is an electrical dipole, the ramp with the ball on it is a mechanical dipole, but the source potential is always the same. It's the ether from the environment. In this case, it moves to the terminal of the battery, then it flows over the surface of the wire, because the wire is like a waveguide. It's just kind of telling the ether where to go down to a lower potential. And then when you have a ramp, and let's say you got a ball and a ramp there and a ball and a ramp there, there's no potential difference there, but there is here. And when it rolls down here and it comes into here, there's no more potential difference, but it did work. So you're creating an asymmetrical situation for gravity to push down on the ball, because gravity is a push, it's not a pull. And in this case, the ether moves to the potential of the terminals, flows over the wire, and that's where you get your electricity. So this is basically kind of unifying the idea between gravitational potential and basic electricity, because the source potential is the same thing. The source potential is the thing. The source potential is that ether, which you take, and then you create an asymmetrical relationship between the ether and whatever you want to do work. And so it's all about polarizing the ether, and that's basically what a dipole does. There's more details in Chapter 3. And we'll go ahead and end this, and we'll move on to Chapter 4.